an amazing fact of statistics is that the same data that gives you an estimate will also give you an assessment of how accurate that estimate is. I don't think the AI world is terribly interested in error analysis. I think they will become so
Well, wait a
after.
minute. We have a common axe to grind here then. You know, I like to think of linear regression as the protozoa of AI, certainly machine
Yeah.
learning. I built this model shortly after I looked at your book on bootstrapping. And you don't have to read the numbers, but we have
Yeah, I see. Yeah.
Y's going in. And we have a regression. And if you had the regression just in Excel, you could ask Excel to give you things like the standard error and all kinds of stuff. And then you said, but wait a minute, you're just assuming it's normal. Is it really? And how would we tell? And well, what would happen if we randomize the data, bootstrap the data? So here I have sample 1 through 10. Let's look at the next sample. Oh, it's 3, 3, 6, 7, 9, 8, 5, 7, 10, 10. Okay, and then the next one. And whenever I do this, right, we see the regression line.
Yeah.
And blah, blah, blah. We do it 1,000 times. And then we see, oh, the standard error was not normal.
So this is a thing that people write to me about. I did this and I got that kind of multi thing, and I always send the same answer. That probably means you have a small number of outliers, and the second peak has to do with when you happen to get more of those outliers in your bootstrap sample.
Yeah.
And
But I mean,
that shows you something about your original calculation. You were lucky that you didn't have that in your original data. You could have easily had that in your original data.
absolutely. And that raises the philosophical question about how multimodal the universe is. Because frankly, and this is the beautiful thing about the Metalog distribution, is it seeks out multi-modes. I'm using the term stochastic data to just mean uncertain data. And here we have a regression. And one, the data is used to train the AI, or in this case, a linear regression. Two, oh, have you heard of a predictive model? Yeah, y equals mx plus b. It's the model created by the linear regression. And then, of course, if you have a forecast, then your predicted demand for 2025 is 100,000. And oh no, you're back to the flaw of averages again. We did not want a single number. That's the last thing you want. And the way I define that is, you know, if you're rolling dice, would you want the number 3.5 on this famous average die that we've created? 3.5 dots on each side. That's just so nuts. But what we do have are the residuals. And that is, we didn't always hit the target with our line. And I like to think of this as a target on a pistol range. And some guy's about to take a shot on a new target, and we have to predict how accurate he's going to be. We say, well, how about if you give us the last 10 targets that we pulled in and let us look at those? I mean, that's really about all it is. So this becomes the stochastic data that gets used in a simulation to give you the correct decision based on the uncertainty.
Another way to bootstrap the regression is to bootstrap the residuals, and that's another way that's used.
Yes, absolutely, absolutely. Or fit some distribution to the residuals or something.
Yeah.
And so does this not apply to all machine learning? I think it does. But what really happens here, of course, is you have the residuals. And then, so we're just asking you not to do that, because the whole raison d'etre of the nonprofit is to figure out how to store these things instead of flushing them down the toilet.